Hello, my name is Ramon, and I want to present the project I've been working on for the last couple of months. icRamp is born in ETH Prague, in the hackathon where I won the bounty for ICP for integrating the RPC EVM canister. And since then, I've been working for increasing some features, adding, for example, different login methods, authentication tokens to secure the application, adding different tokens for the orders in different chains of EVM, but also integrating ICP payments in the orders. So basically, users are everyone that wants to buy crypto or sell crypto. Basically, the idea is very simple. It's just a P2P market where some people sell crypto and others buys it. And then our platform will take care of validating in a decentralized fashion all the payment details and then transferring the funds and validating it accordingly. So the pain point it addresses is this one, just the lack of trust in centralized exchanges. We are able to provide an exchange that doesn't rely on centralized parties, and we can do it by using the ICP trustless operations like HTTP out calls and other Web2 services and integrations of these APIs. And also, most importantly, the problem we aim to alleviate is this complexity of onboarding. The feel we get in the platform, thanks to the ICP capabilities, is that we can do account abstraction, we can use Web2 like login methods, and we can abstract most of the complicated functionality for all the chains by equal, meaning that we don't need to care about the particularities of all blockchains. We are just having it managed by the ICP ecosystem. Potential market obviously is very big, and also this platform can have different variants and different features added in the future, so it's a good starting point. I think that related to this, one of the standard features is that it's very easy and fast to prototype in the Internet Computer ecosystem. So we can integrate different front-end and back-end canisters, and we have a highly scalable environment. We can deploy to production very fast and test the features. For example, next steps would be to integrate Solana and Bitcoin payments in the orders, and also adding different kind of goods in the marketplace, like P2P cross-chain swaps. Now I would like to show how the platform feels. So if we switch to the front end, I will create two accounts, one for the offramper and another for the onramper. Indeed, the offramper one, it's already created. So I'm logging it as an offramper, and here I will create an onramper account. So now the session token is being created, and we can already perform actions in the platform. Let's focus first on the onramper. To register, we need to provide the PayPal ID or the Revolut. In testnet, this works, but it's not deployed in production. So let's proceed with the PayPal one. We are going to add a sandbox PayPal account, so we just register like this. And now the token is created again. So now there's no orders. Let's create one with the offramper. The offramper, as you see, has 25 ICP, and the onramper has nothing. We can also create the wallet, connect the wallet to create EVM orders. We can add the addresses here, and we can do different things with the profile. So if we switch back to the create order, we are going to create an ICP1. If we sell an ICP, we select the PayPal, and now we are just transferring the funds, and the backend creates the order. For this price, it calculated the fees, some fees for the offramper, and some fees to maintain the canisters. As you see, instead of 10, we subtracted 0.005. So now, if we come back here and we refresh the page, we see that there's this order that we can lock. So we just fetch the price. Now the prices are set exactly at this point, and we can proceed to PayPal. And proceed to the payment. Now the payment is received by the backend, and it's being verified. And now it just releases the funds, and we see that now the order is completed, and the onramper has the amount of ICP stated in the order. And also, if we go to the profile now, we see that the score increased. That means that the score means the ability of users to create or lock orders. If it goes below 0, the user will be considered as blocked. And also, we can see here in the different currencies the ramp amount. So if we come to the repository, you can check and explore the code. In the README, I try to explain all the documentation necessary and add some screenshots for the use cases and all the information for the project. So this is what we saw in the front end. And then basically to show a bit of the main important parts of the code and the components, this is what we have. We are defining a front end, a backend, and this backend is communicating with the HTTPS outcomes canister, the EVM RPC, and the exchange rate canisters. So basically, we saw more or less the front end, how it will query the backend, and the backend will create all the necessary memory states, management, and all this. The authentication as well, we have some detail here to how we retrieve the tokens with the different login mechanisms, and also how we validate it and we store it in our memory. This can be checked in the part of the session management. And this is a quick overview, a very simplified overview of how the backend calls the HTTP outputs canister. Then the EVM RPC canister is the most, the management of the EVM RPC canister is the most complex one, because we need to keep track of the nonce, we need to keep track of the logs, and we have different retry mechanisms like dumping gas fees, or to report the failures and to manage them automatically, and performing actions on the success behind the scenes. Also managing the nonce gaps and all this. This is the most extensive part of the code. Then also the communication with the exchange rates and how the front end logs all the transactions and queries all these logs and all these actions. So just a quick overview of the main functions here. We are registering the ICP tokens and the EVM tokens. It's very easy to add new ones, but we need to keep track to ensure for safety reasons. And for example, when we register the ICP token, we get the symbol of the ledger, the decimals, and the transaction fee. So everything can be handled automatically from them. Then for registering the tokens, it's a similar process. And then for the balances, the RPC EVM canister adders can withdraw the fees, and basically it can be funded automatically. This is not in a timer yet, but it's just very easy. It will be added at some point that, for example, every day or every week, it just withdraws the fees for the different chains, so it's funded without human intervention. For the users, we have all these actions, and also related to the session token. The session token is being checked at all points. For example, when adding the payment provider, we will just validate the session, and also everywhere. And for the order prices, we need to retrieve them using the exchange rate canister somewhere inside here. For the orders, we create them, we log them, and then we verify the transactions and we complete the orders. So we have two kinds of storage. We have the heap storage, where we store the some counters and some timers for the locked orders. The locked orders are currently locked for 30 minutes, so the timers take care of checking what locked orders are not locked anymore and change the state internally. And also here, this is what I commented about the EVM logs mechanism for retrieving the transactions and managing the nonce gaps and the bumping the fees and all these features. And then we have the stable memory, where we store the users, the orders, and then the processed hashes, which are used when creating the order, since the off-ramper is signing the operation in the wallet. It's the only moment where the user needs to interact with the wallet. So we are checking the logs, and we are making sure that this transaction is not being yet used to create any order. This is accounts for the stable memory, and so on and so forth. So basically, this is all the architecture. And also you can check a bit more in detail in the Notion part. Let's see here. You can check, this is for the onboarding, for login, for example, the different methods for logging, or for creating orders as offramper, or onrampers for receiving crypto, and so on and so forth. And for a bit of a more technical discussion is happening here, how, for example, the retry mechanisms I was talking about, they are described here, specifically here for the retry mechanisms, to dumping the fees and all these. So you can get a bit more of the details here. And basically this is